What if distance didn't matter anymore? What if we could bend space like paper, connect to stars with a single fold, and travel thousands of light years in the blink of an eye? Science fiction has teased us with this dream for decades. So buckle up, because today we redive into the heart of one of the most mind-bending ideas in modern science, and asking the question, could humanity one day bend space itself and travel the stars at faster than light speeds? Star Trek made it famous. Pop culture turned it into legend. Then came ships, trains, airplanes, each one shrinking the world just a little more. But space doesn't care about our technology. Even our fastest spacecraft, like the Parker Solar Probe, travels at just 430,000 miles per hour. At that speed, reaching the nearest star system, Alpha Centauri, would still take us over 6,500 years. That's longer than all of recorded human history. But deep in the equations of modern physics, a strange truth is hiding. Warp drive, the ability to travel faster than light, might not be fiction at all. In theory, it could allow a spacecraft to sit still while the universe moves around it, like surfing a wave of curved spacetime. It sounds impossible, but it's not. Because in 1994, a physicist named Miguel Alcubierre took this idea and ran with it. And what he discovered shook the foundations of physics. They're deeply connected, forming a four-dimensional fabric known as spacetime. And here's where it gets weird. This fabric can bend. Massive objects like planets and stars curve the spacetime around them. The more massive the object, the more extreme the curvature. This curvature is what we experience as gravity. They don't forbid space itself from expanding or contracting at any speed. In fact, during the Big Bang, space expanded faster than the speed of light, and no law of physics was violated. And if we ever did, what would happen next? In 1994, one physicist dared to go further than anyone before, and actually calculated what this bubble would look like. His name was Miguel Alcubierre, and his paper would turn a wild theory into one of the most exciting and terrifying possibilities in modern physics. Earth doesn't pull the moon like a magnet. The moon is simply following a curved path through the distorted space-time that Earth creates. But bend in space isn't easy. In fact, it may require something that's never been proven to exist: negative energy. Still, this was revolutionary. The math didn't say no. It said maybe. One of them, NASA's Harold White, proposed a new version of the warp bubble in 2011, drastically lowering the energy required. Something incredible happened. It was still enormous, but it was no longer beyond imagination. The Alcubierre metric had turned warp drive from fiction into a real, if distant, possibility. It means the universe might already be warping space invisibly, subtly right now. The discovery sent shockwaves through the physics community. Warp drive wasn't just math anymore. It was something we could start to measure. While studying quantum vacuum structures known as Casimir cavities, they observed a warp-like energy signature, something that resembled a miniature Alcubierre bubble. Private organizations like the Limitless Space Institute are funding warp bubble research, and if warp drive becomes real even in the next century, it will change everything. Colonizing distant exoplanets. If warp bubbles are possible, even rare, then a civilization millions of years ahead of us could be traveling that way already. Maybe they don't use radio waves. Maybe they never left clues because they don't travel through space. They travel around it, and maybe they've already been here, mining asteroids and neighboring star systems, exploring the galaxy not with rockets, but with ripples in reality, because space isn't empty. It's a fabric, and soon we may learn to shape it. The scientific world is asking serious questions. Can we manipulate vacuum energy? Can we create fields strong enough to curve space? Can we navigate a warp bubble and survive? No, it wasn't an engine, but it was the first physical indication that warp bubbles might naturally occur in the quantum vacuum. Subscribe for more journeys beyond time, light, and reason. We'll see you on the other side. Negative energy or exotic matter is theoretical stuff with truly bizarre properties. It could repel rather than attract. It could push space apart. It would be the fuel for the warp bubble. And while no one's managed to create or harness negative energy in any useful way, there are hints from quantum physics, from the Casimir effect, from black hole studies, that it might not be just fantasy. Some of the brightest minds in physics are taking this seriously. NASA's run simulations. Space really curves around mass, and if mass can curve space, maybe there's a way to manipulate space intentionally. Warp technology is still out of reach, but not as far as we thought. And if we ever master it, the implications are staggering. Because once we bend space, we bend everything. It would compress space ahead of the ship and expand space behind, creating a wave-like distortion in the space-time fabric. Inspired by Star Trek and working with Einstein's equations, he asked a simple but profound question. What if faster-than-light travel wasn't forbidden, just misunderstood? The ship would sit in the center of this distortion, inside a stable region known as a warp bubble. Within the bubble, everything would be normal. The bubble would contract space in front of it and expand space behind, allowing the ship to move faster than light relative to outside observers, while remaining motionless inside. This became known as the Alcubierre metric. And for the first time, faster-than-light travel had a real mathematical framework. No acceleration, no g-forces, but from the outside, the bubble and everything inside it would be traveling faster than light. That's the core idea behind warp drive. Scientists have detected something shockingly similar to a warp bubble. To do that, we turn to one of the most groundbreaking theories in the history of science, Einstein's general theory of relativity. In 1915, Albert Einstein didn't just change physics, he changed how we understand reality itself. The math checks out, and what's more terrifying or thrilling is that no known law of physics says it's impossible. Welcome to the Sirius Hub. Chapter 1. The Dream of Instant Travel. From the earliest days of human history, distance has defined our limits. Our ancestors spent generations walking across continents. So what do? Do we accept our fate, trapped in this tiny bubble of space around Earth? Or do we challenge the impossible? Fiction writers have always had an answer. They dreamed of hyperspace wormholes, teleportation ... But unlike teleportation or wormholes, warp drive has something special. It's rooted in Einstein's own theory of general relativity. That's where things get strange. Because according to Einstein, space isn't just empty, it's something real. Something that can stretch, compress, and bend. And if you can manipulate space itself, then maybe, just maybe, you don't need to travel faster than light. You just need to bring the destination closer to you. This is where the idea of warp drive truly begins. Not with moving faster than light, but with moving space itself. Chapter 2. The science of space-time. Before we can understand how warp drive might work, we need to understand what it would actually be. According to his theory, space and time are not separate things. So when we say space is curved, we're not speaking metaphorically. Rather than forcing a spacecraft to accelerate through space, a warp drive would bend the space itself. And here's the kicker. Einstein's equations allow for this. This loophole in Einstein's math is exactly what opened the door to serious discussion of warp travel. The question is, can we produce it in amounts large enough to bend space? Can we stabilize it long enough to create a bubble? Chapter 3. The Alcubierre breakthrough. The world was focused on the internet, but Miguel Alcubierre was focused on something else. Using Einstein's field equations, Alcubierre proposed a theoretical model that would allow a spaceship to ride inside a warp bubble. But there was a problem. To create and sustain a warp bubble, Alcubierre's model required an enormous amount of negative energy, perhaps equal to the mass of Jupiter. That opened the floodgates. Physicists began refining the model. They tried new bubble shapes and energy configurations. And then, Chapter 4. Warp bubbles. Fiction meets physics. In 2021, Harold White and his team made a surprising discovery. And if nature already allows warp-like structures to exist, that changes everything. It means this isn't just a theoretical construct. Scientists like Eric Lentz even proposed models that could create warp bubbles using only positive energy, removing the need for exotic matter entirely. Chapter 5. NASA and modern efforts. The road to real warp. Today, NASA continues to research advanced propulsion, including warp theory. We're not there yet, but for the first time, we're trying. And then, the final question arises. What if someone else already figured this out? Warp drive may sound like science fiction, but the math is real, the research is real, and the future is wide open. So keep watching the stars. This is the Sirius Hub, where science meets the edge of the impossible.